Hello my dear students, today I will discuss with you about the history of periodic table. The modern periodic table arranges the elements by their atomic numbers and periodic properties. Several scientists worked over almost a century to assemble the elements into the format. Here we are seeing the modern periodic table, and in the periodic table you are seeing the elements are arranged by the atomic number. Here you see there are groups and these are periods. Okay, these are alkali metals, these are alkaline earth metals, these are transition metals, these are non-metals, these are halogens, these are noble gases, these are lanthanide series, these are actinide series. Okay, so we start our history, how scientists arranges the periodic table year after year. Then we start. First, Antony Lavoisier. In 1789, Antony Lavoisier first divided the elements like oxygen, nitrogen, hydrogen, phosphorus, mercury, zinc, sulfur, etc. into metals and non-metals. After 40 years of Lavoisier, then in 1829, Dobereiner found that groups of three elements show the same kind of features. It is known as Dobereiner's law of triers. Dobereiner's law of triers. Dobereiner identified chlorine, bromine and iodine as the first trio of chemical elements. Here you see the Dobereiner's periodic table. There is Dobereiner's law of triers. According to law of triers, lithium, sodium, potassium, calcium, strontium, barium, they are the same group of elements. He organized the elements into three according to their atomic mass. Then he marked that atomic mass of the second element is half or near about half of the summation of first and third atomic mass, such as half of summation of atomic mass of chlorine and iodine is equal to atomic mass of bromine. Here you see according to atomic mass, we are seeing that atomic mass of chlorine is 35.5, atomic mass of iodine is 127 and atomic mass of bromine is 80. But if we eat atomic mass of chlorine and iodine and divide it by 2, then we get 81.25. It will near about the atomic mass of bromine. And according to atomic number, we see the same result. Atomic number of bromine, and after calculation we get the atomic number of bromine. They are same. Here you see the law. According to law of triers, there are 5 groups. You see here 1, 2, 3, 4 and this 5. So now we will see what was the limitation of Dobereiner's periodic table. You see, the identification of new elements makes this model obsolete. Newly discovered elements did not fit into the triads. Only a total of 5 Dobereiner's triads were identified. You see this previous slide. Even several known elements did not fit into any of the triads. Okay, then we go to the next slide and we will discuss about law of octet. In 1864, and it is missed here, in 1864 the English scientist John A.R. Newland, 1864. British chemist John Newland was the first to arrange the elements into a periodic table with increasing order of atomic masses. Look at this. This was the increasing order of atomic masses. They found that when elements are arranged in the increasing order of their atomic masses, the properties of eighth element are the repetition of the properties of first element. Every 8 elements have similar properties and called this the law of octet. Let's see how. Here you see, here is hydrogen. This is the first element, and after that lithium, gallium, boron, carbon, nitrogen, oxygen, and after that this is fluorine. And the properties of hydrogen and fluorine is near about. And then after that sodium, magnesium, aluminium, silicon, phosphorus, sulfur, and the eighth element is chlorine, and his properties is similar to hydrogen and fluorine. But there was some mistakes. What was the mistakes? The elements with dissimilar properties were grouped together. For example, the halogens were grouped with some metals such as cobalt, nickel, and platinum. You see here cobalt, nickel, platinum, palladium, this. He assumed that there were 56 elements in nature, but now we see that there are 118 elements. Newland's law of octaves held true only for elements up to calcium. Elements with greater atomic masses could not be accommodated into octaves. The elements that were discovered later could not be fit into the octave pattern. Therefore, this method of classifying elements did not leave any room for the discovery of new elements. You see, there is no space for new elements. Okay? After that, Mendeleev. Dmitry Ivanovich Mendeleev, a Russian chemist, was the most important contributor to early development of the periodic table. Many periodic tables were made, but the most important one was the Mendeleev periodic table. In 1869, after the rejection of Newland's octave law, Mendeleev periodic table came into the picture. In Mendeleev's periodic table, elements were arranged on the basis of the fundamental property, atomic mass, and chemical properties. During Mendeleev's work, only 63 elements were known. He organized 63 elements in 8 vertical columns and 12 horizontal lines. Elements belonging to some column have same physical and chemical properties, and in each line they change gradually as they progress from left to right. Let's see Mendeleev's periodic table. Here you see the Mendeleev's periodic table. Here you see there are some blank space for new element. Okay, and here is a element according to atomic mass. According to atomic mass, 1.01, 6.94, 9.01, 10.8. These are arranged according to atomic masses. Mendeleev predicted several elements after observing his periodic table. He estimated that some unfilled spots would be similar to elements existing in the given group. Thus, there will be some elements, their chemical properties or physical properties will be same of these elements. So he left space. He named some element as Eka, where Eka means one in Sanskrit. Mendeleev predicted Eka boron, Eka aluminium, Eka manganese, and Eka silicon. These elements were later discovered to be scandium, gallium, technetium, and germanium, respectively. Mendeleev also predicted an element between thorium and uranium, amongst others. Here you see, after Mendeleev's arranging periodic table, there were some new elements invented and they are placed into the blank space. You are seeing this germanium, this. Okay, and here is helium, neon, argon, krypton, xenon, radon. All these elements were invented after Mendeleev's periodic table, and they were arranged here in the blank space. The first element to begin with did not have a definite place on the table. It was placed differently from the rest of the elements. This is hydrogen. Isotopes are variants of a particular element that have the same atomic number but different atomic mass. We know that what is isotope? The atomic number is different but atomic mass. They have same atomic number but different in atomic mass. And these isotopes violates Mendeleev's periodic table as they could not be placed. The increase in the atomic mass of the elements is irregular and not in a fixed pattern. Argon with atomic mass 40 placed before potassium with atomic mass 39. You see here. Okay. Then we go next. Now I will discuss with you about modern periodic table. Modern periodic table, you see here the modern periodic table, and here it indicates alkaline metal, alkaline earth metal, lanthanide, actinide, transition metal, etc. So now discuss about Moseley, who arranges the modern periodic table. In the year 1913, Henry Moseley studied the frequencies of the X-rays which were emitted when certain metals were bombarded with the high speed of electrons. He found that in all the cases, the square root of the frequency was directly proportional to the atomic number of the atom of the metals. These studies believe that atomic number is the fundamental property of an element. In the above observation, Moseley gave the modern periodic law, which was physical and chemical properties of the elements and the periodic functions of their atomic number. So he arranges the periodic table according to atomic number. When the table was recognized according to atomic number of elements, argon came automatically before potassium, and thus the flaw in Mendeleev's table was corrected. International Union of Pure and Applied Chemistry has so far detected 118 elements. UPEX supervises and controls different matter of chemistry and applied chemistry. Lavoisier started with only 33 elements, which became 63 detected and 4 undetected elements in Mendeleev's table. Now that atom has turned out to be the modern periodic table with 100 detected elements. Thank you. Love.